In this lesson we're going to be looking at the reaction rate of a chemical reaction in the context of the particle model. That's to say, in what is known as collision theory. So we're looking at how reaction rate depends upon how particles collide with each other. So what we can say is that for any reaction to take place, then the reacting particles, that's to say the particles of the reactants involved, must collide with each other. So let's make a note of that. Collide. Collisions between particles are absolutely essential for any reaction to take place, and these collisions must take place with enough energy. Okay, so the particles have to have sufficient energy for the reaction to occur. Now let's just look at this, for example, in the context of, say, the reaction between hydrogen gas and chlorine gas. So let's just say we've got a molecule of hydrogen and a molecule of chlorine, and so these are flying around all over the place with a whole range of speeds and directions and colliding with each other left, right and centre. And so what we're saying is that in order for these two molecules to react, there must be a collision. That's collision theory. So in comes our chlorine molecule from this way, and in comes our hydrogen molecule. They collide with each other, kapow, and as a result of this collision, the bonds are broken and the individual atoms separate. So we get a collision, the bonds are broken, then the individual atoms will then recombine to form the new substance, which in this case is hydrogen chloride. So we get new bonds formed, we get the new products. Okay, in this particular case then HCl. Yeah, so we're going to get two molecules of hydrogen chloride formed from the hydrogen molecule and the chlorine molecule. Okay, so this will not take place unless there is a collision, and that collision needs to have sufficient energy to break the bonds in the hydrogen and chlorine molecule. Okay, this energy is known as the activation energy, so we'll look at that in a minute. So bearing in mind that a reaction requires a collision, and a collision with sufficient energy, then what factors will affect the rate at which a reaction takes place? Well, the first important factor is how often the reacting particles will collide with each other. So what we want is for these collisions to be a maximum. So the more collisions we have means that the reaction rate will be higher. And the frequency at which these collisions occur, that's to say how many collisions will be taking place per second, will depend upon four factors. We're going to look at each of these factors in much more detail in the following lesson. So I'm just going to briefly go through these with you now. So the first factor is the temperature of the reactants. That's going to affect how fast the particles are moving and therefore the number of collisions which occur per second. Next is the concentration of the reactants. If we're talking about, for example, a solution, or the pressure of the reactants if we're talking about gases, for example. Next is the surface area of the reactants involved, and finally whether or not we're using a catalyst. So all four of these factors will affect how often a collision takes place. And as I mentioned earlier, the second important factor is not only how often the reacting particles collide, but also with how much energy they possess on each collision. Okay, so just repeating, we require energy to break the bonds of the reacting particles. In this case, it was the covalent bonds of the hydrogen and the chlorine molecules, but we might be talking about ionic bonds, or we might be talking about metallic bonds that need to be broken during the reaction. So we require energy to break the bonds, and this energy, as we learned in the section on enthalpy changes, is known as the activation energy. Okay, so we'll look at this in a later unit, but what we're saying is that the kinetic energy of the colliding reacting particles must be able to supply this activation energy, which is required for the reaction to proceed. And what we'll learn in the following lesson is that this energy is only affected by the temperature of the reactants. Okay, whereas the number of collisions which are taking place per second, the rate of collisions, is affected by all four of these factors: temperature, concentration, surface area and catalyst. The actual energy of the colliding particles is only affected by the temperature. It is not affected by the concentration of the reactants, the surface area of the reactants, or the type of catalyst used. We'll look at that in the next lesson.